go for let's go to next topic, that is all about generating function. So in last class we have just understand what is canonical transformation with the help of Jacobian as well as the Poisson bracket. Now today we will learn how we can generate this canonical transformation. Idea is very simple. We have a Hamiltonian that can be function of small q, small p, and t. And what we have to do, we have to transform it to the new Hamiltonian. And the new Hamiltonian is function of capital Q and capital P, and it may be explicit function of time. And the transformation between H to K is via some beautiful transformation, and that is known as what? Canonical transformation. So what we have done into last class, that my H is function of generalized coordinate, generalized momentum, and time. This is a small one. We just want to go a new Hamiltonian that is function of generalized coordinate, generalized momentum, and time. The beautiful part is that this Hamiltonian have to follow the equation of motion, and that equation of motion is nothing but the Hamiltonian equation of motion, where del K upon del Q must be equal to minus P dot, and del K upon del P is equal to Q dot. So this have to be followed, and the transformation between here to here can be a function which can be written as small q can be written as capital Q and capital P, and small p can be written as capital Q and capital P, or vice versa. Another way of transformation is also possible, that this Q can be function of a small q and a small p, and this p will be function of a small q and a small p. It may be function of time also, so there is not any problem. And this transformation have to canonical in nature. And if they are canonical in nature, that means the Poisson bracket between Q and P, and that must be equal to 1. And obviously this Poisson bracket is with respect to small q and small p. So this thing we have learned into last class. Now, how you can get this type of canonical transformation? How you can generate this type of canonical transformation? This is all about the scope of generating function. So let's try to go for a generating function. But before going to generating function, let me ask you one very simple question. What is the basic rule or basic principle behind the all Lagrangian and Hamiltonian formulation? Puneet, what is the basic formulation? What is the basic formulation behind all these things?
Sir, to arrive at equation of motion.
To okay, no. What is the base? That is your outcome. The equation of motion is outcome. Okay.
Degree of freedom.
Obviously, degree of freedom. That is one way of using that thing. But what is the basic principle behind this thing? What is the basic principle?
Sir, Hamiltonian principle.
Hamiltonian principle is principle of least action.
Yes,
okay?
yes.
Hamilton's principle, not
yes,
Hamiltonian.
Yes.
Hamilton's principle. So
Yes.
you can see the most important principle that will govern all these things is the principle of least action. Principle of least action. Isn't it? This is most important thing that should be governed by the law of nature. And what is the principle of least action? You have to define the action, and this action is nothing, L dt, and you have to just go for del A must be equal to 0, means the particle will follow that path where action of a system is going to extremum. And once you define the action of a system, then only you can just formulate the Lagrangian. And once you can formulate the Lagrangian, then you can, sorry, you can just go for Hamiltonian and Hamiltonian equation of motion. And once you know the Hamiltonian, then you can easily formulate the Poisson bracket. Look at the connectivity. And the source of all these branches of classical mechanics is nothing from principle of least action. Are you people comfortable?
Yes, sir.
Hannah? So if this Lagrangian is going to follow principle of least action, this Hamiltonian must also follow principle of least action, isn't it? Why? Because we can write our Lagrangian as a function of Hamiltonian. At the same time, we can write our Hamiltonian as a function of Lagrangian. Is that any problem?
No, sir.
No. So what is the principle of least action as a form of Hamiltonian? So obviously the Hamiltonian is defined as summation over pi qi dot minus L, and L can be written as summation over pi qi dot minus h, and h can be function of generalized coordinate, generalized momentum, and function of time. So this Hamiltonian have to follow this particular principle of least action. What I am trying to say, I am just trying to say that you can just go for summation over pi qi dot minus h, and that should be qi pi t dt must be equal to 0, isn't it? I am just writing the same thing. I am just writing the same thing as a function of Hamiltonian. Are you getting my point, everyone? This is very interesting. This is very interesting. So please keep focus on all this thing. Now, if this Hamiltonian is going to follow principle of least action or Hamilton's principle, then this K, which is famously used by the Goldstein, that is known as Camiltonian. Goldstein ने इसे क्या कहा? Camiltonian. इसे Hamiltonian, इसे Camiltonian. Just for the sake of writing the big Q and writing your Hamiltonian as a function of big Q and big P. So we have just using this particular K, that is what? Camiltonian. Everyone is comfortable?
Yes, sir.
So what will happen? So if this Hamiltonian is following the principle of least action, this Camiltonian must be also follow principle of least action. Yes or no?
Yes, sir.
Exactly.
Yes, sir.
Now, left hand side is going to be 0. That means you can easily make them equal. अगर
Yes,
लेफ्ट हैंड साइड 0 होता तो क्या आप डायरेक्टली इक्वल कर लोगे?
No, sir.
किसी चीज से मल्टीप्लाई कोई डायमेंशन
Obviously, कुछ वैसे चीज से मल्टीप्लाई करना पड़ेगा. That will be a function, that is will be some function of some differentiation. अगर मैं अंदर वाले चीज को इक्वेट करना चाहता हूं तो let me write first, then we will explain it. यहां तक तो क्लियर है ना everyone? And this is nothing but the principle of Hamilton's principle. Okay. This is nothing but what? Hamilton's principle. Now let's go for next step. Now, if this is going to be correct, then what I can do, I can write this whole thing is pi qi dot summation over I minus h ui pi t. I am just talking about inside the integral part, must be equal to lambda time, and this lambda is very famous Lagrange's multiplier, which will be used to balance the dimension. दोनों तरफ के डायमेंशन को बैलेंस करने के काम में आएगा. And we have pi qi dot minus k qi pi t. क्या मैं डायरेक्ट ऐसे लिख दूं क्या? लिख करके काम खत्म करें? दोनों तरफ तो जीरो ही था. No, you
No,
cannot
sir.
write something like this. What you have to do, you have to just take a function, and that function can be a function differentiation of time. अब आप देखो, अगर आप दोनों तरफ इंटीग्रेट करते हो विथ रेस्पेक्ट टू टाइम, आर यू गेटिंग माय पॉइंट?
Yes, sir.
आप दोनों तरफ रिक्वेस्ट इधर भी dt ले आओगे, इधर भी ले आओगे dt, and you will just have integration term. Okay? And then you will integrate this f also, isn't it?
Yes, sir.
So this f will be something like a constant of integration type thing, isn't it?
Yes, sir.
है ना? And now this f will actually help you to establish the relationship from left side as well as right hand side. And that f will chosen very intelligently such that you can have a different type of canonical, that it can give you different type of canonical transformation. And for lambda is equal to 1, for lambda is equal to 1, the transformation is canonical in nature. Are you getting my point? For lambda is equal to 1, the transformation is what? Canonical in nature. So
Nature.
this is very interesting, and this f will help you to define different type of generating function. And now, hence, what is my aim? My aim is that I have to establish the relationship between capital Q as a function of small q and small p, and capital P as a function of small q and small p. Then what should be the nature of this all generating function? The nature of the all four generating function must be a combination of old coordinate as well as new coordinate. Are you getting my point?
Yes, sir.
ये f जो होगा उसका ये काम ही होगा, हम उसे जनरेटिंग फंक्शन कहेंगे जो कि एक दूसरे के साथ कॉन्जुगेट वेरिएबल के रिलेशनशिप दें. So obviously, what is meaning of that? If you have one variable, so f must be function of old variable as well as new variable, because the purpose is that if you know the generating function and you know the one variable, you can easily calculate the another conjugate variable. And same time, if you know the one variable, another one, and then you can easily find the conjugate to another. Let me calculate this thing first. Let me derive one or two things. Then you will understand what I am going to try to say. So how many type of generating function you can create? कितने तरह के generating function बना सकते हो? 4 तरह के बन सकते हैं. So first type of generating function is basically f1 type, and that will be a function of q capital QT. f2 type q capital PT. f3 type small p, sorry, capital, just a minute, So small p, capital P. So this will be small p and capital Q and T and F4 type generating function, small p, capital P and T. सारा possible हो गया ना? Just you can check it.
Yes, sir.
है ना? Let me check. भाई मैंने कुछ गलत तो नहीं किया? The small p, capital Q, yes. So they are all 4 type of generating function. And these 4 type of generating function must be perfect differential. ये कैसा होना चाहिए? Perfect differential होना चाहिए. What is meaning of that? Meaning of that, if you are going to talk about df, that means this must be equal to what? 0. Now, first we will see that how we are going to calculate it, and then you will just surprise that this is used into different places into physics. The famous Maxwell relation in the thermodynamics. Have you heard about it? Yes.
Yes, sir.
The source of all these Maxwell relation is from this particular generating function. The conjugate variables. We will discuss it in the last of our class. But before that, let's try to go for a different type of function. And in last class, one student have asked this thing, that why we want to do the transformation. We will see why we want to do the transformation. Okay, so let's try to go for F1 type generating function.
सर df by dt ये कांस्टेंट है क्या, जो इंटीग्रेशन लेने के बाद मतलब बीच में ऐसा मतलब फंक्शन कैसे आ गया?
क्या बोल रहे हो?
df by dt ये कांस्टेंट है क्या, मतलब जो फंक्शन आएगा वो ऐसा कुछ है क्या?
नहीं, कांस्टेंट नहीं है. df upon dt is not a constant.
मतलब
Constant of integration and constant to the thing are different thing. Are you getting my point?
नो सर एक्चुअली
भाई कांस्टेंट ऑफ इंटीग्रेशन फंक्शन हो सकता है,
हाँ
वही चीज हो सकता है.
ओके
अभी यहाँ पर प्रॉब्लम करेंगे, आपको समझ में आ जाएगा, डोंट वरी. ठीक है. सो लेट्स ट्राई टू गो फॉर F1 टाइप जनरेटिंग फंक्शन. तो आज हम लोग मेनली F1 टाइप से चीजों को समझने की कोशिश करेंगे, एंड वी विल रिमेन लिटिल बिट स्लो, एंड आफ्टर देन वी विल गो फॉर very fast in the next class F2 type, F3 type, F4 type generating function. Okay.
Yes, sir.
So what we have basically lambda is equal to 1. So we have to remove it. So F is equal to F1 type generating function, which is function of old coordinate, new coordinate, and it may be function of time. This is your F1 type generating function. So this F1 type generating function is going to satisfy this one. So if it is going to satisfy this one, then what you have pi qi dot minus h qi pi and t, and this is equal to pi qi dot minus k, this is qi pi t, plus here you have del f1 upon del qi summation over I qi dot. ठीक लिख रहा हूं ना? And second thing, plus del f1 upon del capital qi dot, plus obviously last but not the least del f1 upon del t, dt upon dt is 1, and we can have all the possible generalized coordinate. Clear है ये?
Yes, sir.
So what we will do, क्या करेंगे हम? We will just try to equate the coefficient on both sides. So let's try to equate the coefficient of qi dot on here and qi dot on here. What will happen? We can have del F1 upon del Qi is equal to Pi. Yes. And second coefficient we are going to equate is Qi dot on left hand side. So if you will take the Qi dot, then you have Pi plus del F1 upon del Qi is equal to 0, and we have del F1 upon del Qi is minus Pi.
हाँ सर, सेकंड वाले में कितना क्वेश्चन इक्वल किया आपने?
इसका
ओके ओके,
Qi dot उधर तो है नहीं,
यस यस सर,
ठीक है?
Yes.
तो ये आ गया आपका. Okay. Now you can see the beautiful part is that if you know the generating function, and this generating function is a function of a small qi, capital Qi and time, then you can easily find what is the conjugate variable. So I am insisting that my function must be either one function of old one and one will be new one. So that will fulfill our purpose. You can see, we know that F1 is a function of capital Qi. We are just getting what will be my capital Pi. Last but not the least, the thing is that we can also create the Hamiltonian. K must be, and this K must be function of generalized coordinate, generalized momentum, and time. And this can be written as H plus del F1 upon del T. So, and this H is actually function of a small Qi, a small Pi and T, and you can easily equate the Qi as a function of capital Qi and capital Pi, Pi as a function of capital Qi and capital Pi. And now the thing is that you have to be very much conscious when your generating function is a function of time, then this part will also come into picture. So don't try to write directly the thing. If you have generating function, we will try to solve one or two problem where generating function will actually function of time. And you can see the thing is going to change very nicely. So what you can have this relationship. You have somehow you can estimate what is your generating function. And once you are going to estimate this generating function, you can easily write what will be your conjugate variable. And once you know the conjugate variable, you can find what will be your new Hamiltonian. Everyone is comfortable? So
Yes,
let's
sir.
try to do some basic problem. So first problem I will do very trivial one, but second problem I will try to give you all the question you have in your mind. Okay, and we will just try to solve all this thing. Okay, let's try to go for it. चलो. So first we will go for what? Very trivial problem, है ना? बहुत trivial problem को देखने की कोशिश करते हैं. And then we will go for a non-trivial problem also. Okay. So suppose I have F1 type generating function, and this generating function is very trivial, that is Q and capital Q. लिख सकते हैं,
Yes,
है
sir.
ना? दिस इज योर जनरेटिंग फंक्शन, वेरी ट्रिवियल। इससे आसान क्या हो सकता है? दैट शुड बी फंक्शन ऑफ स्मॉल क्यू एंड कैपिटल क्यू, है ना? So this is F1 type generating function. So let's try to go for what are the canonical transformation. So let's try to go for next one. So what is the rule? Del F1 upon del Q is equal to what?
Minus pi dot.
Pi.
Yes, sir.
याद रखोगे इसे, del
Yes, sir.
F1 upon del Q is equal to माइनस, या आई देने की जरूरत नहीं है, दैट विल बी ओनली माइनस है। क्लियर है ये? So let's try to use this one. What is meaning of that? Capital Q is equal to small p, and here small q is equal to minus capital P. What you are going to do? You are just trying to change the variable small q to capital P and p to and small q to capital P and small p to q. तो जो आपका q था उसे p कर रहे हो और जो आपका p था उसे q कर रहे हो. Why you are using that is different thing. But yes, if you are going to check this transformation, you will find this is canonical in nature. अगर आप इस ट्रांसफॉर्मेशन को चेक करोगे, you will find it is canonical. How you will check? You can easily check this thing. You have to just go for Poisson bracket of Q and P, and once you are going to this particular thing, del Q upon del Q, del P upon del P minus del Q upon del P and del P upon del Q. What is del Q upon del Q? 0. So this one is 0. Del Q upon del P, that is 1. And del Q upon del P upon del Q, that is minus 1. And that value is 1. So this transformation is nothing but canonical in nature. So if you have this type of transformation, this is trivial, and you can see we are just changing one generalized coordinate to momentum and momentum to coordinate. So why we can name it as a inverse transformation. So you can name it as a inverse transformation. This is wonderful. So this is one type of, and I am 100% agreed with this with you that they are very trivial one. But in fact, even if it is very trivial one, we can learn a lot of things from this particular transformation. So now my question is going to reverse. And what is my question? My question is that if this is my transformation, means P is going to capital Q and Q is going to minus capital P, what should be my F1 type generating function? Means if transformation is given, I can also calculate what is my generating function. So let's try to go for a reverse calculation and we will just check my transformation is this one. Now you can see we have to use this relationship. So what is this relationship? Del F1 upon del Q is equal to P. Now F1 is function of a small q, capital P and T. Is that
Sir?
this small p is your favorable variable or not? क्या ये small p आपका favorable variable है? हाँ या ना?
Excuse me.
Yes.
Sir, F1 small q capital Q T है ना?
Sorry, small q. हाँ,
Yeah,
sorry. Small q. ठीक. Sorry. Good, thank you. So is that this small p is my favorable variable?
No, sir.
No. F1 must be function of small q, capital Q and T. So what I have to do? I have to replace this p from here. So what is this value? Del F1 upon del Q can be written as capital Q. from this particular transformation. Now we are going to integrate this particular thing. When we are going to integrate it, what I will get? I will get F1 is equal to, you can just go to integrate. This is partial integration. So what is the meaning of partial integration? You have to always think very carefully. When it is going to integrate it, then Q, capital Q, plus integration of constant, and that integration of constant will be function of what?
E.
Function of?
Sir, capital Q.
Function
Capital
of
Q.
capital Q, because here variable is small q. So it may be function of capital Q. Some person have asked me, sir, what is that? Can you see that in constant of integration can be function of some variable, isn't it?
Yes, sir. Got
है
it.
ना? So you can have this thing. So now this is my first equation, and you have to always use the second equation when you have to calculate it. In the trivial problem, it may be that you can use the first equation and you can give the answer. But when we are going for the non-trivial problem, then you will see that you have to solve the both these equations simultaneously. This is very important. Now, again, we are going to use the second equation. Now, just tell me, is that capital P is your favorable variable or not?
No, sir.
No, that is not our favorable variable. So del F1 upon del Q is equal to minus, sorry. So the minus sign is there, and this P can be written as minus Q. Look at, be very careful. Now again we are going to integrate it. When we are going to integrate it, then what will happen? My F1 will be again Q, capital Q, plus integration constant. Now this time what will be that integration constant? That is function of what? अभी आपने सेल कॉम्प्लेक्स में भी किया होगा ये.
Small
रियल
q.
पार्ट दिया है तो इमेजिनरी पार्ट निकालना, इमेजिनरी दिया तो रियल, किया था ऐसा?
Yes, sir.
Yes, yes.
उसमें भी इस तरह का यूज किया होगा,
Yes.
isn't it?
Yes, sir.
Got it.
है ना? सम मिलनी एक थ्योरम
Milne
टाइप
Thomson method.
यूज
Yes,
किया
sir.
होगा, है ना?
Thompson method.
Yes. You can see everything is connected, isn't it?
Yes, sir.
Yes. So F2 is a function of what? Small q. And now you can equate it. And when you are going to equate it, make the algorithm that this mix function must be same. ये mix function जो है वो दोनों तरफ क्या होना चाहिए? Same होना चाहिए. And now you can find the function of only capital Q in this equation, and you will find the function of only small q into this equation. Are you getting my point very carefully? Again, I am repeating. You have to find only function of capital Q into this side, and you have to find only function of a small q into this side. Fortunately, this is very trivial. You have F1Q is equal to 0 and F2Q is equal to also 0. Yes? And
Yes,
so,
sir.
what is your F1 type function? Is your small q and q, which is basically inverse function. Inverse transformation that will give you inverse transformation. So I deliberately chosen this particular very simple problem, very trivial problem, because we want to learn the process. Once you learn the process for the trivial one, you can easily go for the non-trivial also. What will happen in the non-trivial? क्या होगा? Changes क्या होंगे non-trivial problem में? Anybody can tell me?
सर एक तो F1 F2 0 नहीं आने के चांसेस.
नहीं आने के चांसेस. एग्जैक्टली, वेरी गुड, वेरी नाइस. सो आपको ये हमेशा फोकस करना पड़ेगा कि हो सकता है कई प्रॉब्लम में ऐसा, जो कि हम लोग नेक्स्ट क्लास में जरूर करेंगे, कि कई प्रॉब्लम में ऐसा हो जहां पर ये चीजें आपकी जीरो नहीं हो. आर यू पीपल हैप्पी विथ ऑल दिस आर्गुमेंट, और यू वांटेड टू ऐड समथिंग, और यू वांटेड टू रिमूव समथिंग?
डाउट है.
बताइए.
बेसिक सा है.
क्या
आपने
आया है?
जब बेसिक है एकदम, मतलब आपने जब फंक्शन इक्वेट किए ना,
हाँ.
तो F1Q स्मॉल q नहीं आएगा क्या? मतलब कंपेयर करने के टाइप q इंटू कैपिटल Q है ना, तो स्मॉल q नहीं आएगा.
यहां पर
हाँ मतलब F1Q ये जब आप इक्वेट करें तो
अच्छा देखो फिर से तुम्हारे मैथमेटिक्स पर थोड़ा ध्यान दो। आलोक सर ने भी पढ़ाया था कॉम्प्लेक्स, पढ़ा था उसमें।
हाँ हाँ पढ़ा
चलो
था।
फिर से उसको जाके आज रिवाइज करोगे। यहां बताओ मैं किसके साथ इंटीग्रेट कर रहा हूं। यहाँ ये इक्वेशन में
स्मॉल
इंटीग्रेट किसके साथ कर रहा हूं, बोलो।
स्मॉल क्यू।
स्मॉल क्यू के साथ इंटीग्रेट कर रहा है, वेरी गुड। सो वेरिएबल क्या है? अच्छा इसको जरा बोल करके दिखाओ तो मुझे, ये क्या बोल रहे हो, इसे बोल कर दिखाओ।
डेरिवेटिव ऑफ F1 विथ रिस्पेक्ट टू स्मॉल q1 स्मॉल q is
बाय
equal to
एज्यूमिंग कैपिटल क्यू इज कांस्टेंट,
constant.
दिस इज पार्शियल।
Yes.
नाउ यू कैन गेट द आंसर।
Okay.
आप
It should
वेरिएबल
be
किसे कर रहे हो, क्यू को कर रहे हो वेरिएबल, तो क्यू का
हाँ।
तो इंटीग्रेशन होगा।
हम्म
लेकिन पार्शियल इंटीग्रेशन कर रहे हो तो फिर बाकी जो बचेगा वो क्या होगा, कांस्टेंट की तरह ट्रीट कर रहे हो। आप इसको
हाँ
फिर से मेरे साथ बोलो। डिफरेंशिएटिंग F1 विथ रेस्पेक्ट टू Q बाय एज्यूमिंग कैपिटल Q इज कांस्टेंट, बोलो मेरे साथ।
differentiating F1 with respect to small q by assuming capital Q as in constant. So it should be
कांस्टेंट,
constant.
सो वाई दिस F1 इज ओनली फंक्शन ऑफ कैपिटल Q। ठीक है,
Okay.
अब सेकंड वाला को जरा मुझे समझाओ। सेकंड वाला कहां गया, ये है ना, ये है। अब यहां यहां बताओ क्या है, बोलो बोलो, बोलना पड़ेगा, बोलो, बोलना जरूरी है।
Differentiate F1
हम्म
with respect to capital Q by
हम्म
assuming small
हम्म।
q as a constant.
तो कांस्टेंट ऑफ इक्वेशन क्या होगा, कांस्टेंट ऑफ मोशन, सॉरी
Constant
कांस्टेंट ऑफ इंटीग्रेशन क्या होगा।
will be the function of a
यस,
small q.
स्मॉल क्यू विल बी द फंक्शन ऑफ स्मॉल क्यू।
Small q.
व्हाई इट इज फंक्शन ऑफ स्मॉल क्यू,
Because that is another is the variable, no? Capital
दिस
Q
वन
is
इज वेरिएबल, सो अनदर
the
इज यू आर यूजिंग दैट डेफिनेशन दैट इट इज कांस्टेंट।
yes sir.
फिर से बोलो, फिर से बोलो, चलो फिर से बोलो इसे।
And differentiating F1 with respect to capital Q, assuming small q as a constant.
So when you are going to integrate it, then the constant
Another
of integration will function of
will be the function of cap small q.
small q, because this is variable, isn't it?
Yes sir.
Now it is clear.
Okay sir.
तो घर में जाकर के एटलीस्ट 4 बार बोलोगे इसे, ठीक है। और जब भी प्रॉब्लम करोगे तो इसे बोलोगे, ठीक है। चलो लेट्स गो फॉर दिस। So let's go for one very nice problem. So I think my class will extend it little bit 10 minutes more. Okay, so don't be panic, है ना। So एक हम लोग बहुत ही ब्यूटीफुल प्रॉब्लम करते हैं एंड दैट इज इन द ग्रिफिथ बुक। और ग्रिफिथ बुक से, सॉरी नॉट ग्रिफिथ, गोल्डस्टीन, गोल्डस्टीन, ओके सॉरी, हार्मोनिक ऑसिलेटर, ठीक है। एवरीवन लव्स हार्मोनिक ऑसिलेटर व्हेन यू आर अ स्टूडेंट ऑफ फिजिक्स, isn't it? So let's go for understanding this particular harmonic oscillator. So let us see, harmonic oscillator is defined as p square upon 2m plus half m omega square q square. Are you happy with this harmonic oscillator?
Yes, sir.
Now, when we are when we are going to solve this particular harmonic oscillator, then let's see what is going to happen. We have to solve Hamiltonian equation of motion, and what will be that? Del H upon del Q is equal to minus P dot. So this value is basically m omega square Q is equal to minus P dot. Yes. And second thing is, del H upon del P is equal to Q dot, which will equivalent to P by M is equal to Q dot. Again, we can differentiate it. So we can get from here P dot is equal to MQ dot, MQ double dot actually. And I can put it here. So what I will get? I will get P double dot plus, sorry, P dot is equal to MQ dot. So we will get Q double dot plus omega square Q is equal to 0. And this is nothing but the second order differential equation. Are you getting my point?
Yes, sir.
There is nothing but the second order differential equation. And on the basis of initial condition, we can find that Q can be function of A sine omega t. I assume at t is equal to 0, the Q is 0. So then we can have this sort of equation of motion. Are you getting my point? We can easily solve it. ये क्वेश्चन आसान है या टफ है?
सर अभी तक तो आसान है.
आसान लग रहा है. Okay. Let us try to make it more simpler. ठीक है, देखते हैं इसे और भी सिंपल करने की कोशिश करते हैं. So let us go for F1 type generating function. So what is your F1 type generating function? We are just going to use F1 type generating function m omega q square by 2 cot q. So is that it is suppose this is my F1 type generating function. What we want a new Hamiltonian. I just want to transform this Hamiltonian to new Hamiltonian as a function of Q and P. Are you getting my point?
Yes, sir.
So what I have to do, I just want to find capital Q and small p as a function of capital Q, sorry, small p and small q as a function of capital Q and capital P. Are you people happy? Okay, so let's try to go for this. So del F1 upon del Q is equal to what? P. यही है ना? So you have m omega q cot q is equal to small p. ठीक लिखा है?
Yes, sir.
And what is second one? Del F1 upon del Q is equal to minus P. So what will happen from here? यहां से क्या हो जाएगा? M omega Q square by 2 is treated as a constant and cot Q का differentiation क्या होता है?
Cosec square q.
या माइनस साइन के साथ?
Minus cosec square q, sir.
Exactly. Minus cosec square Q is equal to minus P. So this minus sign is cancel out and I can write my Q as a function of that is a function of 2p upon m omega root under 1 by cosec is what? Sine.
Thank you.
Sine Q. Am I correct? ठीक लिखा हो ना?
Yes,
Yes,
sir.
sir.
ठीक है. And I will put Q here and then I can get a small p. Q तो मिल गया, small p को यहाँ put करें,
Yes, sir.
है ना? So then I can get a small p. So what will happen? So this small p is basically when we are going to put it, m will come out. So this will be root under m omega p. 2 time is also there. into, so what is cot q? Cot q is nothing, cos by sin. Then sin and sin will cancel, and here we have cot q. सही लिखा हूं मैं? जरा चेक करो तो.
It will be cos
Cos, not cot. That is cos. Are people happy?
Yes, sir.
Absolutely. Now let us try to go for next step. यहां तक क्लियर है ना? ये भी एग्जाम में आया हुआ है कि जस्ट ये जेनेटिक फंक्शन है, क्या होगा आपका ट्रांसफॉर्मेशन. ओके, नाउ लेट्स ट्राई टू फाइंड द न्यू हैमिल्टोनियन. And once you are going to find the new Hamiltonian, that is K, that is H plus del F1 upon del T. Fortunately, this F1 is not a function of time. So this value is equal to what? 0. So my K is equal to P square by 2m plus half m omega square q square. Now we have to put the value of p square. So when you are going to put the value of p square, what you will get? 2m omega p by 2m cos square q plus what will be next one? Half m omega square. What is your q square? Where is my q?
A sin
दिया क्या?
omega t, sir. A sin omega t.
Huh?
P equal to A
P
sin
upon m
omega
omega
t.
into sin square q.
2p upon
m
m
omega
omega sin
sin
square
theta.
q. Okay, शायद मैंने मिटा दिया ना? Okay, don't worry. So what will happen? This value is equal to omega p by 2, I can take common, and you have cos square q plus sin square q, and your Hamiltonian is omega p by 2 या सेम आ रहा है?
सर 2 नहीं
P
है
2
omega.
नहीं आएगा. 2 to cancel. Okay, okay. 2 to
Yes,
cancel. Okay. So omega p into cos square. So that will be omega into p. Look at this is your harmonic oscillator. Can you assume that this is harmonic oscillator?
No, sir.
This is your harmonic oscillator. Don't worry. You have done so beautiful transformation that you have this k is equal to what? Omega into p. What is this omega? What is this p? Mathematically, we can understand, and now we can solve the equation of motion. Let us try to go for equation of motion. Now, you can see how we can use this particular transformation. Even if it has a well-known solution, we can simplify this problem to this one. Now, look at here. So you have k is equal to nothing but omega p, and you can have del k upon del q is equal to minus p dot, and here this value is equal to what? 0 is equal to minus p dot. So p must be constant. My goodness. This is just behaving like a free particle when we are going to transform it. But how it is behaving like a free particle? It is not a free particle. So what is constant here? We have to identify what is this p. Is that linear momentum is constant, or something else?
No, sir.
Something else is constant. We have to identify with our intuition. And now next part is very interesting. So del k upon del p is equal to nothing but q dot, and you will have this omega is nothing but what? Q dot. Are you getting my? And what is your solution from the original Hamiltonian? Original Hamiltonian का solution क्या है जरा बताइए तो?
A sin omega t.
Something like A sin omega t. Q is something like this, na?
Yes, sir.
Okay, look at here. So I can find Q dot is equal to omega. So Q is equal to omega t plus some phi. And phi is integration constant, that is initial constant. And look at what is your transformation. आपका transformation क्या था? Q को हमने कैपिटल Q के स्मॉल p के टर्म में क्या लिखा था? Just you can assume. क्या था बताइए? Root under 2p upon m omega, and this will be sine Q, isn't it?
Yes, sir.
And you can have this Q is equal to 2p upon m omega sine omega t plus phi. Look at here. And this is your amplitude part, and this is your phase part. मिल रहा है आपको? Exactly same जगह पर आप पहुंच गए.
Yes.
Now the question is that what is this particular p? ये p क्या है? कहां से आया ये p? What is meaning of this capital P? What is this particular thing? If we want this k have to behave like an energy, then this p must be something like angular momentum, isn't it?
Yes, sir.
And which is constant in nature. And you will surprise that some great person named have write the energy of harmonic oscillator as something like h cut omega. The great person was none other than the great Planck's. लिखा था उन्होंने?
Yes, sir.
हार्मोनिक ऑसिलेटर की एनर्जी को क्या लिखा था उन्होंने? h cut omega. If I want this k have to be behave like energy, then this p must be angular momentum or the dimension of angular momentum. And you can see that this angular momentum is conserved, and Planck's use this particular concept. And what is say that conserved quantity is nothing but identified as that is universal constant. He treated this conserved quantity as a universal constant, and that universal constant is what? H cut. Remember?
Yes, sir.
And what is dimension of H?
Angular momentum.
Exactly dimension of angular momentum. So now you can see the connection between the quantum mechanics and classical mechanics here. Hold your nerves, isn't it? Look at harmonic oscillator, simplest system. But how you can see the harmonic oscillator into another part. But thing is that this is nothing but the linear harmonic oscillator. I am 100% agreed. P and Q, let's say P is Px and Q is X. This is linear harmonic oscillator. So from where you have this angular momentum is it's just going to come into picture. Can you think about this? So think it and give me answer into next class. I will discuss into next class. Okay? If you have any doubt, you can just raise the question. Everybody.
Sir,
Huh?
sir, how can we decide that here we will use F1 type generating function?
How you will decide? That is very good thing. That is very good thing. Good. Obviously, this is intuitive. Why it is intuitive? Look at this equation. ये किस चीज का equation है? If I am just trying to plot versus P versus Q.
Ellipse.
Ellipse. Very good. Ellipse. और ellipse की पैरामेट्रिक इक्वेशन क्या होती है? बताइए.
X square by A square.
No,
plus Y
ellipse की
square by-
पैरामेट्रिक पैरामीटर्स क्या होते हैं इलिप्स की? पैरामेट्रिक में चेंज करने के लिए इलिप्स को अगर आप जैसे सर्कल को चेंज करते हो ना, x इज इक्वल टू a cos थीटा, y इज इक्वल टू a sin थीटा, याद है?
Yes, sir.
उसी तरह से इलिप्स को क्या चेंज करेंगे? x की वैल्यू a sin थीटा ले लो और px की वैल्यू b cos थीटा। नहीं, सो हमने कुछ इस तरह से F1 को क्रिएट किया है कि उसके जो ट्रांसफॉर्मेशन है वो साइन और कॉस के टर्म में आ जाए। आर यू गेटिंग माय पॉइंट? ताकि वो इलिप्स के जो पूरी की पूरी जो पिक्चर है उसको कवर कर पाए। एंड दिस इज इंट्यूटिव, दिस इज इंट्यूटिव, इसका कोई रूल नहीं है। यू हैव टू जस्ट ट्राई टू वर्क विद डिफरेंट टाइप ऑफ जनरेटिंग फंक्शन, डिफरेंट टाइप ऑफ फंक्शन। आपको पहले देखना पड़ेगा कि वो क्या आ रहा है और फिर आपके प्रॉब्लम में सेट कर रहा है कि नहीं। फॉर एग्जाम्पल, अगर मैं यहां माइनस साइन दे दूं तो आप किस तरह की चीजों के बारे में सोचने की कोशिश करोगे? सपोज मैथमेटिकली सोचते हैं, फिजिकली नहीं है, माइनस साइन है, तो किस तरह की आप पैरामेट्रिक इक्वेशन को लेने की कोशिश करोगे? दिस इज हाइपरबोला, दिस इज हाइपरबोला। क्या यूज करोगे? सेक और टेन का जैसा चीज चाहिए आपको कैनोनिकल ट्रांसफॉर्मेशन में, है ना? यस या नो?
Yes, sir.
आज जाकर के थोड़ा सा पैरामेट्रिक जो आप जो चेंज करते हो, थोड़ा हाइपरबोला को देखो, इलिप्स को देखो, किसके पोलर कोऑर्डिनेट में कैसे लिख सकते हैं, क्या कर सकते हैं, थोड़ा देखने की कोशिश करो, तो वहां से आपको इंट्यूशन लगेगा। बट डोंट वरी, आपको उतना अंदर डेप्थ में जाने की जरूरत नहीं है। आप इसका वर्कआउट कर लो और इसे अपने अंदर ले लो, यही बहुत है अभी के समय में। ओके,
Yes, sir.
ठीक है? सो
हाँ,
यू कैन सी, सो माय क्वेश्चन इज दैट व्हाट इज मीनिंग ऑफ एंगुलर मोमेंटम? एंगुलर मोमेंटम का कहां से इसमें एंगुलर मोमेंटम कहां से आ गया भाई? दिस इज ऑल अबाउट लीनियर हार्मोनिक ऑसिलेटर, but you are talking about angular momentum is going to conserve. Yes?
Yes, sir.
Anyway, so don't worry, this question has nothing to do with examination. Exam में just आपको ये calculation करने आना चाहिए. And you can see this Q is cyclic coordinate, capital Q is cyclic coordinate. है ना?
Yes, sir.
Okay. So I think I must stop here. Okay? We will meet tomorrow. So कल हम लोग इसे finish करेंगे and please be ready for test. 6A, 6B, and you are going to give 6C tomorrow also. And then you have premium test. आप टेस्ट देना शुरू किए हो नहीं? Enrollment किए हो या नहीं?
Yes,
Just
sir.
tell me.